F1, F2, M, slotted, sheet, cast iron weights. Masseprazise manufacture of high-precision test sieves, from 32 microns to 8 millimeters. High-precise test sieve manufacturer of as per guideline of ISO standard, ASTM standard, BSS standard. Masseprazise high-accuracy test sieves are manufactured for the critical process industries like pharmaceutical industry, research and development industry, chemical industry, mining and metallurgy, food and agro industry, construction and cement industry, education industry, many more. Test sieves are manufactured with high-grade stainless steel 316 for a durable frame as well as mesh. From 32 microns to 8 millimeters, every sieve we produce reflects our commitment to global standards and exceptional quality. Consistent sieving needs consistent shaking. Mass Prazise Sieve Shaker. Uniform vibration for accurate particle separation, compatible with all standard test sieves. Ideal for labs, research and development, and industrial quality control applications. Easy to operate, durable, and low maintenance. Contact high precision manufacturer of and Sieve Shaker. Thank you for your valuable time.
Good afternoon, everyone. On behalf of Masseprazise, I welcome you all to the core technical webinar on test sieves and sieving processes. Masseprazise is a well-known name for the peerless lab equipment manufacturer, and through this session, we aim to share valuable knowledge about one of the most important tools that is used in particle size analysis, the test sieves and sieve shapers. This session is organized to be informative and practical, and we hope it adds value to your work and understanding. Once again, thank you for joining us. Now I will start the webinar, which is subjected as the core technical webinar, test sieves and sieving processes. We will include basically three parts in today's webinar, that is selection of test sieves, impact of quality test sieves on your process, and the common errors that happens during the sieve selection and during the sieving process. What is a test sieve? So basically, a test sieve is a scientific screening instrument that utilizes wire plot to generate a reliable particle size distribution. Sieves with varying mesh openings and typically stacked on top of each other, working to separate the particles of a material simply based on their sizes. Test sieves are used in all kinds of industries to perform particle analysis. Sometimes the particles are superfine, like in the pharmaceuticals or food industry. Sometimes the particle can be larger, like in agriculture and mining industries. Also in the construction industry. There are basically two predominant types of test sieve used to conduct the sieve analysis. Depending on your sample material, you will either use dry test sieves or wet test sieves. So dry test sieves are used when the particles are free flowing and can pass through the opening of the mesh with just a shaking or tapping motion. Wet wash test sieve are used when water needs to be added to the sample to get the particle to pass through the wire mesh of the test sieve. Wet wash sieving is often used in aggregate industry. Clay and salt stick to the outside of the racks, making them larger than they really are. By adding water to the sieving process, the dirt and silt are cleaned off the outside of the rocks, allowing them to measure properly. A test sieve consists of four main parts, mainly called as frame, usually made of stainless steel or brass. Mesh screen, a wire mesh or a perforated plate. So basically, for screening purpose, there are two types of medium that are available. First one is the wire mesh. Second one, the second one are perforated. See that perforated means the plates with holes, with round holes or with square holes. Third part of the test sieve is a rigid frame on which the wire mesh is uniformly tensioned and welded with precision. And fourth part, that is silicone o-ring. Basically, silicone o-ring works as a reducer of the noise in between the sieving process, and also it controls the particles coming out from the top of the sieves. What is sieving? Sieving is one of the oldest method of classifying powders or granules by particle size distribution. Originating from hand sieving technique, test sieve analysis is a particle size analysis method that has been practiced for centuries, from the coffee ground that gave us a boost throughout the day and up to the fertilizer we use to make our yards crop. Test sieve analysis is responsible for ensuring the product we use for our work as intended. So we can say sieving is the process of separating fine particles from coarse particle by allowing the smaller ones to pass through a mesh or perforated surface, while the larger particle are is retained on the top of the wire mesh or perforated mesh. It relies on this process relies on the physical size difference between particle and does not alter the composition of the material. So, see, by sieving process, the composition of the material remains the same, and only describes the particle size, different particle size that it consists. Types of sieving. So basically, we are discussing about the method of sieving. So there are multiple methods depending on the industry, depending on the material which we are going to sieve. So basically, generally used or mostly used, there are four methods that are mostly used in different industries. The first and very popular method is mechanical sieving or dry sieving. Dry sieving is a method is a common practice for size separation of dry powders and granules. This can be done by using a vibratory sieve shakers or nowadays ultrasonic sieve shakers with stacked sieve trays. Air jet sieving, the process of the sieving is same, but in this method is used for ultrafine powders, especially those prone to agglomeration and or electrostatic sticking. The material stick on superfine material that sticks on the wire mesh. So in this method, the air jet is used to blow the particles through a sieve, while a vacuum assists removal. The process is widely used for micronized APIs, active pharmaceutical ingredient, and highly accurate for particle sizes that are super fine, like 20 to 30 and 45, or we can say below 75 micron. Third method is ultrasonic sieving. This process is used to improve the flow of cohesive or electrostatically charged powders in the process. A high frequency sound waves are used to vibrate the sieve mesh to prevent the clogging. This process is mostly used for very fine powders like lactose, starch, to maintain through output and prevent the blinding of the sieves. Fourth method is wet sieving. This process is used for the powders that don't flow well in dry method. In this process, a liquid, usually water or alcohol, is used to carry the particles through the mesh. And this process is used especially for raw materials like hydrated compounds or powders. Uh, in this process, one thing is very important to remember, that in this process it is important to ensure that the material are not soluble or reactive to the liquid which we are using as a wet medium. So here are the few standards that based on which test tubes are compliant and test tubes are manufactured and sieving processes are being done. So one of the most important thing to understand when it comes to the test tube is the industry standards. So you have to know the industry standard to purchase the correct test tube to perform the perfect sieving process. So a industry standard can tell you the what size of mesh you required, how many number of test sieve you required for a particular sieving, how much sample quantity to be used, if you required a sieve shaker or not, how long you need to run the sample for, and if you need the calibrated or certified sieve or only a compliant sieve. So these types of answer can be get by reading or understanding the industry standard. So test sieve standard relates to construction. Test sieve standard relate to the construction of the test sieve itself, as well as the performance of the sieves. There are most most there are two types of standard that are mostly commonly used. One is ISO 3310, that is a 2016 version, and second one is ASTM E11. Typically, ISO standard are international standard and ESCM is North American standard. There are few more standard like British standard BSS 410, and there are some industry standard that like USP 786, US Pharmacopoeia 786 that is specifically for pharmaceutical industry. Some other industries like mining, like agriculture may have their own standards. So it is very important to identify your requirement of the standard and to follow them. Now we will discuss how the quality of the quality of a test sheet plays the role in our daily saving process and daily quality process, quality analysis or particle size analysis. So we have point out some points that how can the quality of the sieves affect the process of your particle size analyzing. So first one is accuracy of the particle size control. Particle size affect drip viability, resolution rate, blend uniformity, and compressibility during tablet formations. Incorrect or inconsistent mesh sizes can lead to inaccurate particle size distributions that may happen due to variability in mesh openings or may allow oversized or undersized particle through affecting the dosage consistency. Consistency in manufacturing batches. Uniformity between the batches is essential for drug efficiency and regulatory approvals. On no standard or damaged sieves, non-standard or damaged sieves may cause batch-to-batch variability that can lead to failed content uniformity or dissolution testing during the quality control. Third point is contamination risk. Pharmaceutical products must be free from contaminant. Rusting, if not made from the certified stainless steel like SS316, if the manufacturing using some any coarser material like SS202 or SS304, that can introduce metallic particles or a worn mesh can improperly worn mesh or improperly welded mesh joints can trap powders, leading to the microbial growth of cross contaminations. Fourth point is compliance with regulatory standards. Agencies like the FDA, EMA, or WHO requires documented control of saving equipment. Non-compliant seed may lack traceability certification, compatibility to ISO standards or ASTM standard, or with like ISO 17025 or carry calibration lab that could lead to audit failures or regulatory observations. Process efficiency and downtime. Time lost due to equipment failure directly impact the production cost. Closed or damaged sieves reduce throughput, and poor build quality leads to frequent replacement of and unscheduled maintenance. So here are some few features that makes a sieve quality sieve. So we have made a table that there are few features that if you consider that can make a test sieve a quality sieve. First one is certified mesh size. As we know that mesh of a test sieve is the most important part. It should be as per the standard and as per the requirement of the standards. We will discuss later in this slide. So what are the sizes that are being provided by the standards? What are the maximum permissible errors that are provided? So a certified mesh sizes is very important to ensure the precise particle size separation. Frame and mesh material as we discussed earlier, that a coarse quality material can leads to the rusting, corrosion resistance, and hygiene compliance. Laser marking serial numbers. Test sheets are basically identical, and the sizes are also identical. If we consider two sizes of the same range, like 250 micron or 230 micron or 200 micron, so they are very similar physically. So you cannot identify the particular sieve which is either 212 micron or 250 micron or 180 micron. So it is very important that each sieve has a unique serial number to identify it and to enable the full traceability uh, to get the desirable result and valid results. Smooth welds, as we discussed earlier, loose holes or a loose welded sieves may leads to the microbial growth. It prevents the powder entrapment and microbial growth. Compliance with ISO ASTM. So compliance like ISO standard like ISO 3310 and ASTM 11, also ISO 17025, that is a calibration standard. Uh, Complying with these standard meets the your results with the global standard for particle analysis. Sometimes your industry standard will require you to have your test sieve certified or calibrated. So basically, there are three types of sieves available as per standard. One is compliance, second one is calibrated, and third one is inspection. So compliance, inspection, and calibration. So there are three types of sieves available. Now you have to follow your industry standard. What type of sieves is recommended? Whether it is recommended a compliance sieves, whether it is recommended a inspection sieves, or whether it is recommending a calibration sieves. So based on this recommendation, you have to go for either for compliance sieves or inspection sieves or calibration sieve. There is a minor difference between all these sieves, so we may discuss it in later in next webinar or sometimes else. How to select the sizes? So basically, here we have some examples of the standards. We have added some standard sizes. These are only for presenting purpose. So this is not the whole standard. So this is just a page for sample. So this is ISO 3310 2016 version, mesh sizes and technical requirements. So we have one screenshot here. So you can see the sizes here mentioned. So there are some principal sizes and supplementary sizes, and then there are the written maximum permissible error and the diameter, wide diameter it may have. So sorry. So suppose we are taking the example of principal size 710. So in this range we have three sizes. So we may have 630 micron, we may have 710 micron, and may have 800 micron. So all these sizes are the principals are the family of sizes 710. So if we see the table very carefully, the third column is maximum permissible errors. So there are three type of maximum errors that have been provided. First one is average. First one is the maximum aperture size. So this suppose a mesh have 1000 aperture. So the maximum value of a aperture that can have is 101.1 for 710 point. So that means the maximum aperture can be 811.1. That is the maximum value of the aperture on the full screen that a mesh can have, and the average should be the average aperture should be 22.1 22 point plus minus 22.2 micron. So AC when we are taking observations of suppose 100 observations or 150 observation throughout the mesh of 200 diameter. So if we are taking 100 observations, so the average variation should be within the plus minus range of 22.2 micron, and the average of these maximum standard deviation that can be 38.4 micron for these 100 or 150 or 200 observations, whatever we are taking. So maximum so if all the data is within this range, then that means that the mesh is as per the standard requirement of ISO 3310. Second part is nominal sizes of wire diameter. Wire diameter is denoted in nominal size of 710. For 710 micron is 450 micron, and the range is from 380 to 520 micron. Basically, 450 plus minus 15% is the range. So we have a criteria of plus minus 50% for wire diameter from nominal value. So that this is the basic requirement of ISO 3310 for any mesh size. So if a test sheet complies with this data, then that means that your test sheet is as per the ISO standard, whether it is a compliance sheet or inspection sheet or calibration sheet. So there is not much difference. There is very in all three models. There is a very few difference, like sample size, what sample we are taking. So for compliance, we have a recommendation of 20 observation plus for every 100 square foot. For inspection seal, we have a criteria of 100 to 20 to 100 observation per sieve, and for calibration seal, we have some less data, like 50 observations per sieve. Here is a screenshot of USB 786. This is just for reference. If you see that the data in USB 786 is identical to the ISO 3310. Basically, 780 USB 786 is derived from ISO 3310. ISO is the principal document. So as we see for 710 micron, the sizes are same: 800 micron, 710 micron, 63 micron. These are supplementary sizes that may be possible for in the range of 710 micron, and the recommended USB size is 710. So now for a test sheet to be 710, we have to again check the data from the previous value, like in ISO 3310, and the sieve if sieve is complying to this data, then we may use this sieve for our process. Now we are moving to the common errors that may happen. We have divided this in two parts. First one is common errors in the selection of seed, and second one is common errors in sieving process. So while selecting the seeds, so we may have we may check few points that may go wrong. First one is wrong mesh size selection. Choosing a mesh size, those are too fine or too coarse. Suppose you have a requirement of 710 and you by wrongly you have selected 650 or 800. So that may lead to the undesired fine or oversized particle. So choosing the mesh sizes, those are too fine or too coarse for the intended particle size distribution, can lead to undesired fine of oversized or particle oversized or undersized particles pass through, that can affect the blend uniformity, flow properties, and tablet compression. Second error that may happen is non-compliance with the standard. So suppose we are using a seed, or we have selected a seed that is not as per standard, like ASTM E11, ISO 3310, or USB 786 requirement, may lead to regulatory risk, and results are not legally defensible in audits. Third point is using low quality or non-certified seeds. Low quality means poor build, like mesh is pulled away or from the frame, or corrosion prone material, or a non-certified sieve with no traceability. These things may lead to contamination, inaccurate particle sizing, and failure in quality audits. Fourth one is incompatible material. So, if the material of the test sieve is not resistant to the corrosion or reactive with drug substances, then this could introduce metal contamination or leachable. Overlooked frame design, frames with sharp weld or rust finishes may lead to powder entrapment, microbial growth, or contamination risk. Common errors in sieving process: overloading the sieve. Loading too much material at once may lead to insufficient separation, damage to the mesh, and increased blinding. So, what amount of sample to be used can be get from the industry standard, local standard, like in USP 76, it is recommended to use maximum sample size of 100 gram. So depending on the size of the seed, you may use from 15 gram to 100 gram sample, and over than 100 gram is not recommended there. Sorry. Inadequate or excessive saving time. Inadequate or excessive saving time may lead to incomplete separation that may cause file to break down further, mass wear, or unnecessary energy use. Improper cleaning. Cleaning is a very important part of saving process, and for the better life of the sieves, we will also discuss the cleaning process separately after this slide. So saving sieves to be cleaned after every use. Not cleaning a sieve after use or using abrasive tools may use cross contamination or damage to the mesh that can permanently damage the test. Not calibrating or verifying that sieve integrity. Using sieves without regular mesh verification or inspection may cause under, undetected mesh damage, leads to inaccurate results. So we have to verify the test sieve before every use. A physical verification is very important for the test sieve to be used before every process or before each use. Ignoring mass binding or closing. Sieves openings may got blocked, especially with corrosive powder. We have to check before every use. Closing or blinding may lead to the false particle size readings reduced throughout. Incorrect sieving method for material. Uh, for example, using a dry method for instead of wet sieving. So dry sieving used for hydroscopic or electrostatic powders. For clumping and sticking, we use wet sieving method. So it is very important to select the right method as per the requirement of the material, whether we have to use the dry sieving or ultrasonic sieving or wet sieving or air jet sieving that we discussed earlier. So method selection is very important as per the requirement of the material and as per the physical property of the material to be sieved. Manual handling and variability. Inconsistent staking, tapping, or sieving angle by different operators may cause lack of repeatability and reproducibility in test results. So it is very important to handling while the sieving process, and also on before and after the sieving process. So handling of the sieve, handling storing of the sieves is very important to get the consistent result every time. Cleaning of the test sieve, as we discussed earlier, we will discuss cleaning of the test sieve as it is a very important part. So there are a few methods that can be used for the cleaning of the test sieve. Cleaning of the test sieve, cleaning of test sieve properly is crucial to maintain their accuracy and extend their lifespan. So here are some step-by-step guide to clean them depending on the material and what type of material you are sieving. So there are few items that may required for cleaning of the material. Soft brush, either mostly of nylon or a camel hair brush. It is recommended to not to use any metallic wire brush like copper wire brush or some aluminum wire brush. So it is not recommended to use the type of, especially for the fine meshes. They can permanently distort the test sheet. So you always use either a nylon glove brush or a camel hair brush for cleaning the test sheet. A mild detergent with warm water, a ultrasonic cleaner, dry or lint-free cloth, and compressed air. So there are multiple options depending on the how much cleaning is required for a test sheet. So uh, in first process, first gently tap the side of the sieves to dislodge the loose particles. Do not bang it or tap against hard surface. So tap the seed very precisely. Tapping on hard surfaces, this can wrap the mesh. Brush gently. Use a soft brush as discussed, either a nylon brush or a camel hair brush. Use a soft brush to loosen and remove the particles from inside to outside. Brush from inside, from bottom side to outside. So you have to use the brush from inside of the mesh, and then again you can use the tapping process to remove the material, to remove the particles that came out after washing. If this does not clean the sieve, then you can use a combination of warm water with detergent. Mix mild detergent with a warm water. Submerge or rinse the sieve with a soapy water, and you avoid using of a very hot water. So we recommend to use only lukewarm water with added detergent. After that, you can use the running tap water to remove the detergent from the sieve. A ultrasonic, there are many ultrasonic cleaners are available in the market. As we discussed earlier, ultrasonic method use sound frequency to for the vibration of mesh. So this can also remove the particles that are within the mesh. So use a ultrasonic cleaner with a water detergent solution. Place the sieve mesh inside the tank, and run the cleaner for 5-10 minutes, and it will clean the mesh properly. After that, you can use the drying process. So drawing is also very important after cleaning by water or by any other particle and any other substance like alcohol. Cleaning is also there. So if we are using any wet method for cleaning the test sheet, so it is very important to dry completely. So you can use a low temperature dry compressed air to clean the sieve or to dry the sieve. After drying the sieve, you can store it in your storage racks. So there was few tips that important is that do not use any wire or wire brush. Avoid harsh chemical that can react to the sieve material like frame or wire mesh material. So these types of chemical cannot be used. Do not bend the mesh. As we discussed earlier, do not tap very hard, and do never use excessive force on the mesh or on the frame of the test sheet. So bending may permanently bending or using extra force on the mesh may permanently damage the mesh of the material, mesh of the test sheets. That was all for today. So now we will open the chat box. So if you are having some questions, you can post your questions in the chat box, and we will take the questions. We will try to take all the questions for next 5 to 10 minutes, and we will try to answer them. So you may post your questions in the chatting box. So we are getting the questions. Up to which particle size are perforated sieve plates opening mass available? Normally, perforated plates are available from 1 mm to all the sizes uh, to up to 120 mm or 120 mm. So, starting from 1 mm, you can find perforated plates from 1 mm to 120 mm. Second was one question explain about calibration. So for calibration, we have to prepare a separate webinar because as it is a long subject. Uh, how to? I think you are asking how to calibrate the test sieves. So that is a separate process that needs to be discussed in separate webinar. We will take this point and we will try to include the calibration process in our next webinar or coming webinars. How to choose Dr. S. Love Kumar, how to choose a dry sieve or wet sieve. Uh, this totally, as we discussed, sir, this totally depends on the material you are sieving. So if the material is sticking on the wire mesh, it is a sticky material and is not easily passing in dry sieving, then you have to use the wet sieve. So basically, sieves are same both the sieves are same for dry sieving method and wet sieving method. Sieves are same. Only the last one, first one is that is collector sieve is different. That has a output process for water, and the top of the top lid of the sieve, top sieve, lid of the test sieve that has has a attachment for inlet of the water. Rest of the sieves which you are using in between the size for size separation, they are same. So there is no difference for the sieves for dry or wet sieve. They are same. Is there are way to repair particularly partially damaged seat? No, it has to be replaced. Either there are two options. There are two test seat makers that have single uniform seat that may not be repaired, and there are some manufacturers that have a separate ring that can be repaired. So frame can be saved and only the mesh can be repaired. So there are that depend on the manufacturer what type of sieve they are manufacturing. So if there is any sieve and if that you are having any sieve that required a repair, so you can share the image. We can tell you that if that is repairable or not. But repairing is possible. But one thing is important that the most costly part of that the test sieve is mesh. So the costing is almost for the new sieve and a repaired sieve will be the same. There will be very minor difference. Abhishek, before performing powder distribution studies, what mesh sizes we use? It totally depends on the powder you are using. So the powder you are using must have a specification of what sizes it consists on that particular data provided by the provider of powder. You have to that see. So the composite selection of the sizes of the test sheet depends on the composition of the powder. So composition must be provided by the seller who is providing you the powder, and based on that data, you have to use the sizes of the test sheets. from which particle size wire mesh are available. So generally, from 32 micron sheets are available. On special request, uh, sheet test sheets can be made from 30 micron. So we have that capability of manufacturing it from 13 micron, 13, 15, 20, 25, 30, 32. Generally, from 38 or 32 micron test sheets are available in the market from 32 micron. But on special demand, a 13 micron test sheet also can be manufactured. Do you provide any test certificate or compliance certificate along with the test sheet? Yes. At each Masseprazise test sheet, when you ask either you require a compliance sheet or calibration sheet, we will provide depending on that. So if you are asking for compliance sheet, we will provide a compliance certificate for that. Or if you are asking for calibration certificate, we will provide the calibration certificate. Scientific equipment world required enable calibration certification. Yes, that depend on the process and the requirement of your industry standard. Calibration is also required as in pharmaceutical industry. Calibration, NABL calibration is required. So NABL is not the right word. Basically, we see ISO 17025 certification is required depending on the industry in which the test is being used. So as for example in pharmaceuticals, ISO 17025 calibration is required. Is there any instrument available to check sieve size which we can use process mesh quickly? Yes, there are instruments that can be used for checking the test sheet. Especially for the large size test sheets, there are linear mesh counters, there are pen microscope, there are calibrators are also available like magnifying glass with scales. So there are instruments that can also there are go and no go pins for the sizes above 100 micron. So you can use this type of instrument to check the test sheet. Go no go pins are widely available for every size, and pen microscopes are available for fine sizes with scales. So this type of instrument can be used for daily checking of the test sheets. Are test sheets supplied with Class A certificate? Sir, this question is not actually I can't get the question. What is Class A certificate? So basically, as we discussed, there are three types of certificate. One is compliance certificate. Second one is inspection certificate, and third one is calibration certificate. So whatever is your requirement, we can provide any of these certificates. So whatever your industry or process requirement is there, so we can provide you a certificate according to that. If a sieve of particular mesh size is damaged, it is possible to buy the mesh cloth separately without changing the frame. Yeah, this is possible, but it depends on the manufacturer because frame size uh, will it fit on in that particular frame size or not, that have to be checked. So you can contact to the direct manufacturer whose sieve you are using, or for if you want us to change that mesh, then we have to verify. Once we have to check the frame, we have to verify whether our assembly is able to be fit in that or not. Then only we can clear that point that either we can replace or not. So it is important to physically see the frame to repair it. But it is repair if it is repairable. So as I discussed earlier, there are two types of frames are there. One is repairable, and there are some unibody mesh also that cannot be repaired. Generally, what is the frequency of calibration of a test sheet? Are there a guideline regarding the calibration frequency? Uh, for the calibration frequency, guideline is no recommendation is there. Guideline, I have not come through any guideline till now. So you can use your internal process. If I think in USP 786 there is something written. You can post this question on mail to us. we will provide a clear guide. We will provide a clear answer to this. Because right now I am not recalling that point either it is a 3 month, 6 month or 1 year. But I remember that in USP 786 there is some guideline is written, but that guideline is only for pharmaceutical industry. So it depends on which industry you belongs. According to that industry, I may guide you towards the calibration frequency. So I would request you to write a mail on the mail ID given below, sales at the rate masseprazise.com. So you can mail this question to there, writing your industry, in which industry you are using the mass seed. So we will try to answer that question with standard guideline with proof, so that you can use that data for your calibration. Normally, it depends on the use and the quality control process. So you have to perform the in check quality, performs in check quality like using a standard reference material for analyzing the test sheet whether they are working perfectly or not. Or you can find it in your SOP. If still there is a point to be find out, you can write us on mail and we will provide you the guideline, and we will provide you the answer with the guidelines. So thank you all. I think all questions are done. We have taken all the questions till now we have received. So it is now we are closing this webinar. So if you further you have any questions, so we have provided the contact number and mail ID. So you can freely post your questions to the mail, and we will try our best to answer all the questions which are coming to us. Once again, thank you very much.